Hello dear students, I am continuing chapter miscellaneous exercise on chapter 1. So taking questions 9, okay, up to question 8 were completed in the previous class. So just take question 9, that is what? Using properties of sets so that solution nine. A union A intersection B equals to A. We have to show that A union A intersection B equals to A. A union A intersection B equals to A. First, we have to show that this, and then A intersection A union B. Second is and A intersection A union B equals to A. These are very, very important properties also of formula, a special result we can say. Suppose okay, also this can be treated as a special formula 9. So now we have to show that this by using properties of sets. Using properties of set. So to prove first, this is equals to this, something is equals to something related to sets, we have to show that this is subset of this and this is subset of this. That means to prove this, we have to show that this is subset of this and also this is subset of this. So to prove first, we claim means we have to show that left hand side A union B intersection C, A intersection B means this equals to this, means A union A intersection B is subset of A, and A is subset of A union A intersection B. We have to show that this and this. Clear? For this, now since A subset A, you know A subset A, and also we know A subset A, and also because we have to show that this is subset of this. Now we know if any set X is subset of Y and also Z is subset of Y. Suppose this is subset of Y, this is subset of Y, then X union Z means union of these two. This is subset of this is subset of this. Then union of this is also subset of Y. By Venn diagram we can say, see that suppose this is Y. By Venn diagram, suppose Venn diagram, this is Y and X is subset of Y and also Z is subset of Y. Then its two union is also subset of Y. So here, by using this concept, and also A intersection B. What is this? This part. A intersection B. This is A, this is B. Now this part is subset of A. Also this part is subset of B. That is A intersection B is subset of A. A subset A, this subset A. So its union, A union this is subset of A. Since this and also this, so we can get what? A union this. A intersection B is subset of A. First part. This is suppose star. This is double star. So star is proved. And we have to prove this. Okay. So here we see that A union B means what? Total. A union B. A union B. Total. Means A is subset of A union B. A is subset of A union B. Also B is subset of A union B. So, and also we see that A is subset of A union A intersection B. Only single A intersection A union A intersection B. This is A union something. So we know A subset A union B. Also B subset A union B. We know A union some other set, A subset of this. Okay, so B subset B union some other set. So here A union of this, that means A is subset of this. A is subset of this. Since this implies proved. These two are proved. So these are our claim. Hence, thus we get A equals to A union A intersection B. Both are equal. As this subset this, and also vice versa. Thus we get this, hence proved. Hence proved. Clear? By using property of set. First part. Similar, as a similar fashion we can prove second part. Clear? So you have to do it in yourself. Clear? This is equals to this. Clear? We can just like here I will give hint. So this subset, this is equals to this. How can you prove? To prove second, A intersection A union B, a subset of this. Similarly, A intersection union. We have to show this. Okay. For second part, this subset this and this subset this. We have to prove. Clear? How can you do it? First part, A intersection A union B subset A. We know here A, here B. Suppose there are two sets, not A, B for consideration. So this is D. This is what? C intersection D. C intersection D. A intersection some other set. Clear? Here C intersection D, this part. Clear? Now here we see that C intersection D, that is this, is subset of C, because this is C, total this is C. So C intersection D is subset of, this part is subset of C, also this part is subset of D. So this is C intersection D, subset of C, C intersection D, subset of D also. So here we can say A intersection something is subset of A. Clear? So we can write, since we see that A intersection as X intersection Y is subset of X. X intersection Y is subset of X. Clear? On considering in place of X A, in place of Y A union B is a set, in place of X A. Since we see that this, therefore here in place of X, if we consider A, then A intersection A union B in place of Y is another set. A union B another set is subset of A. Here A in place of Y A union B. The study is proved. Clear? And now for this part. And to prove double star, let X be any element of A. Then we have to prove this. Okay? So let x belongs to A, then x belongs to A, then x belongs to A, then x is also belongs to A union B. A union B contains all the elements of A and B. So if x belongs to A, then x also belongs to A union B. Okay. So here A and A union B are two sets. X belongs to A and x also belongs to A union B. That means x belongs to both. So we get x belongs to A intersection, because belongs to A also and belongs to this also. So x belongs to A intersection this. X is in both. So A intersection A union. So x belongs to A, then x belongs to A intersection A union B. Therefore, A subset this. A subset A intersection A union B. That is proved. Is proved. A subset this. Here this subset this. Thus we get what are equal? A intersection A union B is equal A. Hence proved. So this was the solution of question 9. Okay. So you have to do it in your copy and just remember how can you give logic to proof of a relation between sets. Okay. Now take question 10. Question 10. So that A intersection B equals to A intersection C need not apply B equals to C. That means need not imply this B equals to C. That means if we can give an example for which A intersection B, A intersection C are equal but B equal to not C, then our question will be proved here. So that this need not apply this means just consider ABC satisfying A intersection B, B equals to A intersection C, and we see that B equals to not C, if you can set. So solution 10. Let us consider set A equals to 0, 1, B equals to 0, 4, 5, C equals to A intersection B equals A intersection C. A intersection B equals A intersection C. This should be satisfied and B equal not C. We are trying to find such sets. So suppose all contains A and here B and X, Y and Z, W. Suppose we consider like this set. Suppose we consider. Then here A intersection B equals to A intersection B equals to intersection. What? A. A common and A intersection C. A intersection C is equals to A common so we get this, but we see that B is not equal to C, but we see that B equal not C. These are two different sets. That is, this need not apply. B equals. That is, A intersection B equal A intersection C need not imply B equal C. This is the proof of question 10. Okay? Simple. Now, take question 11. Take question 11. Okay? Question 11 gives what? B2 sets A intersection B, these two conditions are satisfied for some set X, then show that A equal to B. Here 11 given what? A intersection X equals to B intersection X. A intersection X equal to B intersection X equals to 5. This is given, and also given B union X. A union X equals to B union X. These two are given. A union X, B union X. For some set X. Here sets AB, for any two sets AB. Given for any two sets. Given for two sets A and B. For some set X, we have to show that A equal B. A equal B. Here you can use any type of technique. These two are having 5. Clear? So we can use properties of sets for proving A equal B. A subset with B subset with A. This is a technique. And also just we use the previous result. What? We know that from question 8, just discuss previous question. In previous question, we know that what? A union, A intersection, A union A union A union then intersection X for a set equals to what? A. If intersection, then here A union X equals to A. We know that this and this. We know that. Okay. First and second. We can use this. Clear? By using this, we can prove. Now from second this A equals to this. So from second we see that A equal A intersection A union X is equals to A intersection A union A intersection X by distributive law. Okay. Now this is equals to A by idempotent. A intersection A equals to A union A intersection X. A intersection X equals to no here na just first in first line just we write A intersection A union X equals to, these are given given relation. So A union X equals to B union X. So intersection B union X. Since A union X equals to B union X, this is given. So in place of A union X, just write this. Now here use distributive law. A intersection B. A intersection B. A intersection B. A intersection B union A intersection X. Clear? Now A intersection X equals to 5. So A intersection B union 5. Since A intersection X equals to 5. This is given. So it implies A equals to A intersection B because of union. So A equals to A intersection B. Okay? This is result star. Clear? A equals to this. We have to show that A equals to B. So here A equals to A intersection B. Okay? Now again use this result for B, for set B. Okay? Again from second we see that for B, use for B. For B set we can also use that result B intersection, you can take any set here, B equal B intersection B union X. You can also use this result. Okay. So this is first result A equal to A intersection B, and here B intersection B union X equals to A union X. A union X. Since A union X equals to B union X given, again distributive law, B intersection A union B intersection X by distributive law. Okay. Now A B intersection A union 5, B intersection X equal to 5. Since B intersection X equals to 5, this is equals to union, being union B intersection A, this is can be written as A intersection B by commutativity. Okay. So we get B equals to A intersection B. This is result double star. So from star and double star we see that these two quantity are same, that is A equals to B. Clear? So finally you can write thus from star and double star we get A equal B. Hence proved. Okay. So this was the solution of question 11. Now take question 12. Take question 12. Here question 12 is what? For set ABC such that A intersection B, B intersection C, A intersection C are non-empty sets and A intersection B intersection phi. So this question I left for you. Okay, so you have to solve it. Question 12. How can you solve? Just consider set, three sets A, B, C. Consider. Think what will be the set. That is A intersection B and B intersection C and C intersection A. These three, A intersection B, B intersection C, A intersection C are non-empty. This should have some value, some elements. You have to consider some sets. Okay? And intersection of each other is non-empty. But A intersection B intersection C equals to phi. Have no element. Just consider and try to find some sets. You can do it. Have 0, 1, then 0, another element, then other element, one of the other element is here, and also from here. Then you can see that this not empty, but the intersection of these three are empty. Just you have to get three sets. So try to find such sets. Okay. So very simple question. Question 12. Clear? Now take question 13. Question 13. We have to solve all questions in your copy and send to me for your attendance. Okay. So here, see. In a survey of 600 students in a school, 150 students were found to take tea, to 25 take coffee. Suppose A be the set for tea. A be the set for tea and B be the set for coffee. Set of students who were found to be taking tea. Set A, B for coffee, 100 over both, 100 over both, A intersection B, both, 100, n of this, A set of student with like what? T. So what? 150. So 150. And B like set, coffee, 225. 225. So 225 number of elements in set B, 225. And both, like both, A intersection B, 100. In survey of 600 students. Okay. How many students were taking neither tea nor coffee? Neither tea nor coffee. Okay. Neither nor means A union B means what? Either A or B. Neither nor, when we take negation, means complement, then what? A dash intersection B dash by De Morgan-Lorentz. You can also. This means neither this nor this, and okay, so we have to find this number of this. This means this, and we can get the result here. Okay, so main thing is understanding what will be the process. So here, if A for tea, B for coffee, A intersection B for both, these are given. We have to find what? Neither A nor B, this number of this. This means what? Neither A union B dash. This means what? Number of element in U minus number of element in A union B. This means what? And U means what? Total. Universal set. What? 600. 600 student in survey. So this minus what? NA plus NB minus NA intersection B. Okay, so this is 600 minus NA NB 150 225 minus plus 100. So we get what? 225 150 375. 700 minus 375. So 325. 325. So this is the number, neither tea nor coffee. So you can use this type of technique. Okay. We know this is equals to this result, a formula. So use this formula, you can get this result. Okay. So miscellaneous exercise, number questions, what? 13. So 1 point. Miscellaneous 13, 325. Okay, good. Now, here, we take question 14. Clear? 14. In question 14, see, in question 14, in a group of students, how many students are in group? Not given. 100 students know Hindi, 100 know Hindi, 50 know English, 25 know both. Each of the student knows either Hindi or English. Hindi and English, either of these, each of the students. How many students are there in the group? Either of these, each student know. That means what? If H represent set for non Hindi and E for English, then H union E is what? Universal set. Because there are not given how many students are in group. Each student knows either Hindi or English. That means what? Union of this is the total number. So that is equal to this. So how many students are there in the group? Means we have to find n of this. N of this. Clear? That is n of this. We have to find this. NH union E equals to what? We know formula. NH plus NE minus NH intersection E. Very simple. NH, what given? NH, NE given, and H intersection E given also. How many students are there? 150, 25. 150, 25. So use result. Here 100 plus 50 plus 25. So 150 minus 25, 125. This is the result. Total number of students are 125. Clear? Now take next question. 15. 14, 15. Okay. Also result is we have to verify result. What? Miscellaneous exercise 125. 125. Okay. Now take question 15. Take question 15. So question 15. In a survey of 60 pupils. Here in a survey of 60 pupils. Total is given 60. And it was found that 25, here three types of mixing, three types. 15, what? It was found that 25 pupils read newspaper H and 26 read T, 26 read I, 9 read H and I, and 11 read H and T, and 8 read T and I. 3 reads all the newspaper. So here how many newspaper are there? H, T, I. So suppose A be the set, A be the set, B be the set, C be the set for reading newspaper H, T and I. Then here we are given what? NA, NB, NC and NA intersection B, NA intersection C and B intersection C and N of A intersection C and N A intersection B intersection C. These are given. Okay, so H 25 for HA 25, B 40, 26, I 26 and 9 read both H and I, H and I, H and I. A union intersection C 9 both, and 11 H and T, H and T AB 11, and 8 T and I, T and I 8. These are given, and 3 read all means this is 3. Okay, so find the number of people who read at least one of the newspaper. Who read at least one of the newspaper means we have to find N A union B union C. This is our main requirement, because at least one of the newspaper reading you can find by using this result. Clear? So for finding this we are using formula. What? N A union B union C equals to what? NA NB NC minus NA intersection B N B intersection C N A intersection C plus N A intersection B intersection C. We know this. This is the formula. So this gives at least one of the newspaper reading pupils. So this is equals to just 25 6 26 25 26 26 minus 11 8 9 11 8 9 plus 3. So what will be the result? 25 25 25 75 76 77 77 minus 77 and 3 80 minus 11 19 28. That is what? 6 The question 15, 28, 80, 30, 52, 52, 52, 52. 80 minus these are 2, 52. So 52 pupils are read at least one of the newspaper from these 3. Okay. Second result. This is first result, first answer, first part. Second part, number of people who read exactly one newspaper. Exactly one newspaper. How can we find exactly one newspaper? How can we find exactly one newspaper? Okay, this is the number of people who read at least one of the newspaper. Okay, now just we get N, A union, B union, C equals to 52. We get this result. No? Now, exactly one newspaper. So here 3 sets are connected. So we can draw diagram like this, this, and this. Clear? This is A. Suppose this is B, and this is C. Now all 3 are here. Clear? And all 3 are here, and A intersection B. Here suppose, A, B, C, D, E, F, G. Clear? Now where number of pupil here? Only A, only B, only C, A, C, G. So we have to find exactly one. Exactly one is A. For this A, for this C, for this G. That is we are requiring the value of A plus C plus G. This is our requirement. A plus C plus G. But here total of all are given. How can you find? You can find from here A plus B plus C plus D plus E plus F plus G is equals to total given what? 52. Total given 52. Clear? Now B plus D, this B plus D 11, B plus D, both A and B 11, B plus D, and BC D plus F, D plus F 8, and AC E plus D plus E equals to 9. Clear? This one, all, and this. Clear? And we can get also many equation are there, just like what? By A means total 4. A plus B plus D plus E, B plus D plus E equals to 25. Okay, just writing here. What? A plus B plus D plus E equals to 25. Now B means what? B C D F. B plus C plus D plus F equals to what? 26. Similarly, C means what? E D F G. E plus D plus F plus G equals to 26. Okay, and this 3 are here. Clear? And D equals to what? Interest 3. We are having like this. And A and B and C all are 52. Okay. Now our requirement is this. By using D, If d equals to 3, then f equals to 8 minus 3, 5. If d equals to 3, 9 minus 3, 6. U equals to 6. If d equals to 3, then b equals to 8. D 3, 11 minus 8. Okay, F, E, B, D. Now, we are requiring the value here D3 if DE, BDE, BDE, 6, 8, 70. These three are 70. So this is 70. So A equal to 25 minus 17, 8. A equals to 8. We can solve here. DF, B, B, DF, 8, 8, 16, BDF, BDF, 8, 5, 3, 8, 8, 8, 16, 16, 16 minus 26 minus 16, 10. So C equals to 10. C equals to 10. Similarly, here, G, for G, na, ED, F, E, D, F, 16, 9, 5, 14. So 14 minus 1, 4, 2, 12. 12. So G equals to 12. Now we are requiring A plus C plus G. A plus C plus G. What? A, 8. C what? 10. G what? 12. So 18, 30. Okay, so result is what? 30. Clear? So this is our requirement exactly on pupil who read ABC, that is HTI. Okay, so by using this we can also find the result. This is our answer, 30. First answer is 52 and second answer is 30. Okay, now in a similar fashion they are given a question 16. 16 you can also solve by drawing this type of diagram and using. In a survey it was found that 21 like product A, 26 like product B, 29 likes product C, ABC are there. So three sets are there. Also you can draw this type of diagram and you can get the result whatever we required. Okay, so do this question 16 also, and by making PDF file send to me for your attendance. Okay, so just use for 16 this method. Okay, and send to me your solution of the questions. Okay, so exercise of sector 1 is completed. You have to reply me today's questions from 9 to 16. Okay.